Hi, in this video we're going to be talking about polymorphism, and we're also going to continue our discussion about inheritance. So just a quick review for inheritance. Inheritance is a process for extending existing classes by adding methods and fields. So we can use one class and then we can extend that class to make a subclass of that class. So when we just did the wombat project, you made a wombat and then you made subclasses of wombats, which would inherit all of the methods and fields from the superclass, the wombat class. So we use inheritance because it allows for reuse of code, and all of this should be review for you. So another thing that should be review is the superclass reference. So the super keyword is to call a method in the superclass or from the superclass. So for example, if the superclass has a method called movement and the subclass has a method called movement, if I wanted to call the superclass's method, movement method, I would have to type super.movement. And the rest of this you can read on your own, but it should be a review using the super keyword. Also remember that for super, you should be calling super to call the constructor of the superclass in the first line of the constructor for your subclass. So this is just another quick review of method overriding. So to override a method, you can have a method called movement in the wombat class, and then you could have another method called movement in the wild wombat class, which is a subclass of wombat. So if you write a separate method for movement, then that overrides the movement method from before. So that means it totally takes over anything that you currently had in the movement class. So it will not recognize the movement method in wombat unless you call super. So in terms of chains of inheritance, a superclass can also be derived from another class. So the object class in Java is known as the cosmic superclass. So all objects, any objects, will come from the object class. So that is like the parent of them all. And the object class has some methods that you are probably used to using and you probably remember. So some of the methods that come from the object class are dot equals, get class, and also toString. So the toString method is part of the object class, and then it can be, you can override it in a subclass of object. So polymorphism, in definition, refers to a programming language's ability to process objects differently depending on their data type or class. So more specifically, it's the ability to redefine methods for derived classes. So for example, if I have a cat, which is my superclass, and then I have a house cat and a lion and a mountain lion, they could all have different speak methods. But if I call speak on all of those objects, they will be able to have their own separate speak methods and do different things. So why is that helpful? So why is polymorphism helpful? Meaning that we could take house cat and we can store it under just the cat class, and we can treat it just as any other cat. So let's look at why that's helpful. So say I'm taking a house cat and a lion and a mountain lion, and I'm putting all of those objects into an array list or an array. So if I do that, then I can loop through that entire array list and I can call the method speak on every single one of those objects as if they're just regular cats, but then the methods will all do what they're supposed to do with respect to their subclass. So you could loop through it and say, okay, cat array dot get I dot speak, and you'd hear meow, you'd hear roar, you'd hear growl. So you would get all of those separate things, and they're all in the same exact list. Here's a sample problem from the AP course description. So we have a dog class, and then we have an underdog class that extends dog. So it's a subclass of dog. And both classes have an act method and an eat method. So assume that the following declaration appears in a client program. Dog Fido equals new underdog, which is the constructor for underdog. What is printed as a result of the call Fido.act? So I'm going to let you guys think about this for a minute. So pause the video and then we'll come back and talk about it. But just remember that Fido is an underdog, right? So it's declared as a dog, but it's specifically declared using the underdog constructor. So it's instantiated using the underdog constructor, meaning that it is an underdog. So if Fido is an underdog, then what would we get from Fido.act? So take a look and pause the video, and we will come back and go over it. Okay, so the answer here is run, eat, bark, and sleep. So if you miss the bark here, then that's pretty easy, a pretty common mistake. So let's go over it. So first you have the fact that this is an underdog, meaning that as soon as you call the act method, it's going to go super.act. So when you call super.act, it calls the act method. So it calls system.out.print run. So we're going to print run. And then we are going to call the eat method. Now the eat method is going to go back into the eat method for the underdog. And that is because there's no specification here as to what method it's part of. So it's going to be part of the eat method since an underdog is in fact an underdog. So now we're going to call super.eat. Super.eat will just print eat. And then system.out.print bark will print bark. And then sleep will get printed because in the act method for underdog, the last thing to be printed is sleep. Okay, so Fido is an underdog. So it has that is a relationship, a very special relationship between a superclass and a subclass. So because Fido is an underdog, then Fido has all the properties of an underdog, even though the first declaration when making the variable is dog. So using late binding, at runtime, Fido uses the appropriate methods of the underdog class. So a call to super.act means Fido will act like a dog where he will run and eat. But when Fido eats using the eat method, the more specific version of the eat method is called, even if the eat method is shown in the superclass method. So now he will complete his underdog act method and sleep. And then if you look at the method calls, you can read these over and make sure that you understand them. Okay, so let's talk about compile time and runtime errors here. So if we have an example where all students can wave, but only some students can speak Spanish. So we have Spanish student as a subclass of student class. Then if we were to make a Spanish student by declaring it as a student, so student X equals new Spanish student, and then we tried to do X.wave, that would be fine because X is a student, it's a Spanish student, but it's definitely a student. And because it's a student, it has a wave method, so it's fine. Then in the next option, we have X.speakSpanish. So you would think that you would be able to do that because X.speakSpanish, well, if X really is a Spanish student, it's declared as a student, but it is a Spanish student, then wouldn't that work? But because the student class does not have a speak Spanish method at all, so it's not like it exists in both classes and it's just you override it in the Spanish student class. It just does not exist in the student class. So this will cause a compile time error. So Java will look at this when you compile, and it's going to be like, oh, no, I'm not seeing the method in there, so it must not work. But technically, there is a Speak Spanish method for a Spanish student. So the way that you can get around the compile error is by casting X to a Spanish student, because right now it's less specific. It's only a student by declaration. So when you cast it to a Spanish student and then you call the .speak Spanish method, it will work because X really does have a Speak Spanish method as a Spanish student object. And then an example of a runtime error is if you have student Y equals and then like ASL student. So this is a different student. It's not a Spanish student. And then we tried to cast Y to a Spanish student and then did .speak Spanish. That would compile because it's saying, oh, Y must, I guess you're casting it to a Spanish student, so you're turning it into an object that would have the Speak Spanish method, but then it's not able to actually cast Y and get the Speak Spanish method out of an object that is not an actual Spanish student. So it'll compile fine, but then it hits a runtime error. Okay, so it's an object type rather than a reference type. That determines which method is called. So for example, you cannot assign a subclass method to a subclass reference variable, but you can assign a subclass object to a superclass reference variable. For example, wombat x equals new wild wombat, that would work. But wild wombat y equals new wombat, that would not work. And the reason being is because if you think about it this way, a wild wombat is a wombat. So can it be stored as a wombat? Sure, because a wild wombat is a wombat. But a wombat isn't always a wild wombat. So if a wombat's not always a wild wombat, then there's no way that we can store it for sure as a wild wombat. So private versus protected versus public. Members of a superclass that are marked private are not inherited by the subclass. So you can't access them without get or set methods. If the variables are protected or public, then they are inherited by the subclass, and for public fields, they're actually accessible for any class, not just the subclass. Be careful with private and public. If you forget the private specifier for an instance variables, you are granting default access. So this is a serious problem on the AP test. On the AP test, they want you to mark every instance variable as private. So even if it's something that you want a subclass to have access to, you should not do it on the AP test. Also on the AP test, they don't cover protected at all. So it's only private and public, and instance variables should always be private no matter what. So always check to see that the methods and instance variables have access specifiers. Again, be careful with private and public. So a public member can be accessed from outside the class, which for practical consideration means potentially anywhere. So if something goes wrong in a public field, the culprit can be anywhere. So in order to track down a bug, you may have to look in quite a lot of code. But if it's a private member, then there's really only one spot that the bug could be. And that's really the reason why private and public and these accessors exist. And that's it. So now at this point, you're going to try a Google form and also respond to this video with one question or comment.